Hello everyone. In this video, I'm going to be going over Lab 5 for CIT 247. What makes this lab unique compared to the other ones you've done so far is that we introduce routers. So these are very different from switches, although they are also used to carry traffic from one destination to another. Switches are confined to a LAN. However, routers actually allow devices in different LANs to communicate with one another. That's what makes these devices very important for internet traffic. So the reason why we taught you subnetting first is because routers actually break networks into multiple LANs, which each need their own subnet. So now that you know what subnetting is, that should give you a better understanding of how they relate to one another. So you can see in this diagram, which you'll be building in GNS, we have a total of 3 subnets, and therefore a total of 3 LANs here. You can see each LAN has its own subnet, and an interesting thing about routers is that each interface they have that's being used is its own LAN or broadcast domain or subnet. They all three kind of mean the same thing to a point. But LAN and broadcast domain more referred to like layer 2. Subnets refer to layer 3 addressing. But anyway, you can see here in each router interface right here, this is a LAN right here, this switch, this computer, and this router interface are all one LAN. Same for router 2's F0/1 port. However, these two right here, this is also one LAN right here. F00, F00. These two are in the same broadcast domain or LAN or subnet. So that's a little hint for one of the questions later on. But anyway, you'll be building this topology in GNS. To find routers, you'll have this little circle with 4 arrows on it. When you go into GNS, click that and you'll have this list of routers. Now there's 2. For this lab, however, it is recommended to use this one, the C3725. Now this recommendation is going to change between different labs. They each have their own features and they have their own quirks with each lab depending on the feature we're implementing. So whenever you're asked to put in a router, please pay very close attention to what the instructions say. Typically there's going to be in the building the topology instructions a recommendation of which router to use. Now, if I'm correct, it really doesn't matter which one you use in this lab, but we do prefer you use the C3725 router just to be safe. It's been tested confirmed to use or to work with this lab. That other one might work, but just stick with this one and you should be fine. So next you'll be configuring router interfaces. So there's basically going to be a command that you use to do this. You're probably familiar with doing switches, but see if I have it right here. So it should be right here. So when you set up an IP address on a router, you just go to conft, you do interface and then interface name. For example, in the lab you have the router interface FA0/0. So you type in int FA0/0. And then you type in the command IP address, and then you type after that 192.168.1.1, for example, and then it's mask. And that's how you configure an IP address on an interface. However, you also need to enable the interface once you configure your IP address. So always type in no shutdown after you put do IP adder or IP address on an interface. So let's see what else here. So right here. Okay. So performing ping tests. This is a big part of this lab. We provide this handy table here to organize your information. So basically from PC1, right here in the topology, so from right here, this PC, you're going to be pinging each and every other device in this entire network here. So your first ping IOU1, router 1's 2 interfaces right here. Because each router interface has an IP address, you're going to be pinging both these active interfaces. You're going to do the same for router 2, and then switch 2, and then PC2. So you'll be doing all of these ping tests. However, you'll also need to well, actually you won't be pinging switch 2, I'm sorry, forget that. But anyway, after you perform these ping tests, you'll need to explain the results, whether they worked or not. So it's more, you need to say more than they succeeded or did not. So if you see here, explanations should discuss the echo request and the echo reply, specifically how the traffic is forwarded from and to back, or from and then back to PC1, the routing decisions PC1, and, if applicable, the routers made. So if your ping doesn't go to router 1 like this switch, you don't need to discuss routing information for this router. So, and then finally, any relevant steps from the IP4 v4 routing process. Now, this is discussed in pages 369 to 371 of your textbook. There is also this PowerPoint, and I'll actually scroll down. This is actually a really helpful PowerPoint for this lab. It talks about how to the router CLI, talks about administrative or interface status codes, how to access the routing table, types of routes. This is going to be helpful later, but the part we're worried about right now is this one: traffic flow and multi-LAN networks. So this information, this whole process right here, this is what you should be putting right here. This process basically explains all three of these requirements. So as long as you follow this explanation right here, it's multiple slides. So long as you follow all these, you should be fine in your answers here. By the way, no minimum length is required because each explanation is going to be of a different length, like a pretty radically different length, but as long as you explain all three of these to a sufficient detail, you'll be just fine. So part 4 will have two parts. The first thing you'll be doing is configuring static routes. To do that, we have this slide right here. This actually gives you an example LAN right here, and gives you the command how to do it. So we can discuss that right here. So IP route is the command you'll start with to make a static route. And if you look at here, let's zoom in a little bit. So if you look right here, the IP route command is what you use to create static routes. And there's three numbers you need to put in here. The first is the destination subnet ID, the subnet mask, and then the IP address of the next hop port or the exit interface. Now that's not IP addresses, that's actually a router interface. So, to explain this here, let's say we want to make a static route from router 1 to router 2, or excuse me, a static route from router 1 that goes to this subnet right here, the 192.168.1.0 subnet. So, to do that, we type in IP route in router 1, and then we type in the destination subnet ID, which is going to be this, 192.168.1.0, the subnet mask of this subnet back here, which is going to be /24. And then we could do one of two things. We could either put the IP address of the router that leads to the subnet. In this case, it would be 192.168.1.0.2. So note that this is the adjacent interface between router 1 and router 2. And router 2 is the one that leads directly to this subnet, or directly hosts the subnet, or however you want to think about it. But anyway, this is the IP address we're looking for. So to think of it this way, the router that is trying to get to this subnet, you take the adjacent router and you take the interface that is connected to the router, or adjacent to it, I should say. Or, if you want to simplify it, you could just take the router interface that leads to the router that leads to this subnet you're trying to reach with the static route. Either way, both result in the same solution, and these are the commands right here. So you'll be applying that in this lab here, but you'll be doing it twice, once for router 1 and again for router 2. They will have different static routes, by the way. That should be pretty obvious. But anyway, let's see, one more thing. Yes, so this part, you'll basically be repeating the ping tests from section 3. The difference is that some of these will succeed. If they do, you can just put results are the same. No need to re-explain everything. To save yourself time, just put results are the same. You can put your yes here. Now, once you configure everything should be yes. Everything should succeed. If something does not succeed, please contact help because you unfortunately lose points if you don't configure your router or network correctly. In fact, you need to be sure you can get PC1 and PC2 to ping, which means configuring correct static routes. If you do configure correct static routes, PC1 and PC2 will ping. If your static routes are incorrect, they will not. So you also need to show proof that you got it to work right here with this question. So, hey, but if you need help, please reach out to me. I'm more than happy to help you all with this. But also, I do recommend the command guide as well. The command guide also explains how to do static routes, shows you how to set up IP addresses and enable interfaces, shows you how to interpret the show IP route or the routing table. And then there's this one other command here, show IP in brief. This will display the all the routers and interfaces and display the IP addresses configured on them. So that's basically it for this route or this lab. If you need any help with it, please let me know. It's a pretty simple lab if you know what to do. Be sure to take advantage of the resources you have, and you do just fine. Thank you very much for listening, and I hope you all have a great day.